Welcome, people in the chat room. I saw that. Hello. Hi, folks. Boy, do we have a lot to cover tonight. So get your list out. We got a couple more things to add to it. And tonight's gym you're going to love. So let's uh, let's get started here. We got a few people kind of rolling in here. I don't want to get late people missing out on the first kind of coverage here, but they can go back into they can replay it and watch it later. So we got to get started here. So here we are. Here's today right here. Okay, we're already kind of getting into tomorrow. This is UTC time. So here's today, right? Okay, the thumbnail that you saw was this little C flare. Okay, now these flares are looking huge. All right, and they're only registering on this instrument as low, or not even M flares, high C flares, which is kind of strange a little bit, especially with the power of these explosions, the plasma, the amount of plasma coming off. It just seems to me these explosions, this one right here is the big one I showed you yesterday. This is the one I'm really concerned about, okay? Right here, but they report it as less than an M, okay? Now, I did not get a good look on the spiral, the Enville spiral of this event and what direction it was going, okay? And I'll talk more about that here later, how hard it is to calculate the trajectory of an invisible object when you only have a few frames. I have to use a protractor on the screen to get my angles for my calculations, which if you're off by 1 degree over the course of millions of miles, it doesn't work. It's really, really hard without proper data. I cannot do proper calculations without proper data. Anyways, so this one is the one that's the next one that concerns me right here, okay? And it's registering as less than an M flare. To me, it looks like an X flare, okay? This looks like an X flare. This looks like an X flare, and we just came off of a real X flare, okay? So to me, this looks like a 3 in a row series that I've seen before. Okay, everybody kind of, oh, cool, there's a few more people in there. All right, so let's get over to, all right, this is the sun's heartbeat again. This is the core of the sun rotating in its shell, putting out its magnetic frequency, and there's pops and squeaks in it because the sun's doing its thing, okay? These flatline things are when it's scary, all right? That's what I don't like to see. This is good activity right here, actually. We're middle C having M class flares, or even less than M class, okay? Now, as we progress here, we're going to go over to the Schumann here, and I'm having, oh no, it's working fine here. All right, good. Take a sip here. Here we are at the Schumann. Line that we're most concerned about. All right, real quick explanation. This is the core of the Earth grinding in its shell, creating a harmonic resonance called the Schumann resonance that we all resonate at 7.83 hertz. It's this green line going across, okay? All these squeaks and pops are the grinding. What I'm most concerned is the strength of this line, okay? The color of it, okay? The power of that line. And this is as tight as I can zoom in. So this is where we take you guys out of the tripod and you come with me over here to the screen. Okay? Now I want you to look. Oh, this is the hard part here. I got to do this with a shattered shoulder and 2 broken wrists. Okay, I think you guys see our line right here. Okay, I want you to notice these dim points right here, really, really weak. This little scratch is a different frequency just off of the Schumann. Okay, so these are odd readings as we're having these low patches here. Okay, here's another just weak. And if you look at this all day, our Schumann was weak. Look at the lower line here. This is another vibration that we've been having for quite a while. Okay, and these two have kind of watch these two because they stay strong. And when both of them go down, look at this stripe right here. See these darker stripes? That's what I'm more concerned about, you guys. Now look how this long period, this long band, this is the core going really slow, putting out a weak signal. Okay, you guys? As I pull back, you can see we have from here to here, this whole day, our shield was really weak. Okay? It wasn't necessarily down. Okay? It was weak. And that's what we want. That's not what we're looking for, okay? That's usually I like to report good news on that one, but today everything looked really weak as we were getting hit with the energy from the first X flare. Okay, you guys putting two and two together? Here, let me plug this back in. Give me a second here. Oh, come on now. It's been a long day, so bear with me here. Okay, so you guys saw the weakness in the Schumann today. Okay, now we had an event today. Okay, and when these events collide at the same time, this is not good. This is not good for the core of the planet. Okay, this little impact right here before it caused this darkening area, caused the core to really go slow, okay, inside its shell. This is its slow rotation when it's weak, okay? When it's nice and strong and proper rotation inside there, we get our nice strong line right across the 7.83, okay? And one of my discoveries of how to read this instrument, if you guys go back a few more videos, I forget which one it was now, I described exactly what this instrument is reading and how to read it, okay? Now, we're moving forward. What was it here that I needed to see? That one was not loaded because I think I got it somewhere else. All right. Let's go over here to, no, to this one. Here we go. All right, hang on. I'm a little discombobulated today. Here is our thumbnail right here. This is February 19th of 2023. All right, we had another CME come off the sun with an object in it. Look at all this plasma. It's ripped off in front. This difference model over here doesn't really show much this time or do it justice. So hopefully my camera will pick up this red side halfway decent tonight. Yeah, and oh, that's what it was. This site had deleted data. So the other site that was loading had the real data. And by the time I got it loaded, this one downloaded the rest. So we're going to this site. That's why I X'd out of that one. So let's go ahead. Let's back out of this real quick. Okay, this is from stereo A. Okay, and what I usually do is I take stereo A and compare it to Soho, which is a straight on view, and I take measurements, angles like this. Okay, and I take a three-dimensional model with the angle, the proper degrees, and I throw it into my formulation, and I can get a trajectory. But this is a two-dimensional image of a three-dimensional event, okay? So the direction is really hard to tell because we don't have depth perception. But what we do have is flow, our flow asymmetries, okay? Well, maybe someday we'll bore the shit out of you with flow asymmetries. But for now, this is way too important. Okay, where am I? Okay, here's our event right here. We're going to pause it, and then we'll go frame by frame through this like we do. Okay, here it is, coming out from behind the occulter. Our instrument's reacting to it. You can see it over here. It's grabbed a nice bit of plasma. And as it's wrapped in this plasma, it's a black spheroid, invisible black spheroid inside a plasma, okay? And as it erupts from that plasma, here's the rest of the plasma tail streaking behind it. See that little curl Q thing right there? Okay. Over here, let's back up just one frame. Nah, nothing. All right, what I need to do here then is go in. Oops. Yeah. Sorry, I have terraphysics, astrophysics, and metaphysics all racing through my head at the same time. I'm in excruciating pain. This is like, I've never been through any kind of ordeal like this. I can't imagine anybody going through this. Anyways, enough of me. Here's our object, our dark circular core right here. Here's the plasma that it's still trailing behind it, okay? It's got the magnetic field. This is where the plasma rides, is on the outer edge of the magnetic field that this little object is creating, okay? And we've seen this over and over and over again. And here's another incident of this object. This is probably another one of these trailing objects from the big one that we saw yesterday. Okay. Oh, it's moving the whole screen. What are we doing here? All right. Let me do it manually then. Let's go over here. Previous frame. Okay. Hopefully the camera is picking that up a little bit. Can I do a shove forward real quick? Okay, you can see our dark round circular patch just like I described, and there's plasma all the way around it. Okay, it's grabbing plasma. It drapes over these objects so you can detect them. That's why else is this plasma trailing behind it? This is a tail of plasma coming off of this object. Okay, and that's today. All right, we do not need any more of this activity. All right, we have this big object, and the trajectory of it is virtually impossible to formulate. Okay, I'm going to do my best, but I have an idea of what's really going on, and it's really hard to do without proper instrumentation and a quantum computer. I can do the quantum calculations if I have the data. Okay, no, there was much more here I needed to cover. So, ta-da, there is our object. Let's go back a few frames, all right? And boom, as it moves out of frame, okay? That was our event today. Then, let me pull back here. Because I think, yeah. I want you guys to watch this area up here. I'm going to go backwards now because both of these are happening almost simultaneously. This one's kind of in slow motion. There's an object out here with streaks going past it. I got to see. It's really kind of weird on this image. But this little pocket, you see these streaks coming back? See this plasma buildup? There's a slow-moving object with a CME behind it, coming around this object faster than it's moving out, leaving this shadow or these streaks, okay? Let me start. I can't reach the... Can we do it this way, God, please? That moves the whole screen. Anyways, this is the best frame of it, and I messed it up. There we go. Okay, right here is about the best frame. You can see this big dip in the red zone right here, okay, with the blue, nice smooth, round face. There's something disrupting this. We all know what it is. It's one of these objects, probably right in here, actually. It looks, I see more circular with this red line going across the middle of the circle, causing this wake, all right? We got something else right here. There's just so much to look at, and hopefully you guys are seeing these links or these instruments and coming over and looking for yourself. Don't just take my word for it. You come over here and play with these instruments, you might see something more than I missed and be like, oh my God, I can't believe what I'm seeing. All right, If you look over here on this red side, you can see this effect. See this plasma streaking past something right here? Okay. Can we get that? Oh, let's just zoom out then. Here. Thank you for your patience, you guys. You can see that I'm kind of low tech here. I gotta just do it the old-fashioned way. All right. Something else. Let's back up a little bit. Does it have it in this? Yes, it does. Oh, I'm just going to run the whole thing. Okay, boom, there's our explosion. Here's our secondary object. But at the beginning of this, I want you to see how much plasma is right here, or how this big yellow streak, see all that? Now watch all of it disappear. I mean, there was a lot going on there. Those two streaks point at these objects like compass needles because they're magnetic. It's pulling plasma off the sun, pointing at the object as it comes in. These little things are, just like I said, like a compass needle, okay? It's another tool I utilize, or aspect I utilize to detect when something's coming in what direction, okay? So we have another disturbance here, and something I wanted to go back to here. Oh, it was stereo A. Okay, real quick, let this loop run. Okay, this caught it from just a better angle, and what's a shame is stereo A used to be behind the sun with another satellite, stereo B, and you used to get a three-dimensional perspective of the sun. Now they've moved this satellite right next to the Earth. So I have to have the degrees between the satellite and the Earth. That's part of the equation. With such a small window with which to work a quadratic equation, it's really, really inaccurate. I mean, I could give it my best swing. Is all I could give you guys is my best swing at it. And I'm pretty accurate, actually, so maybe I'll do some calculations. It's really hard to do with a kid's school protractor on a TV screen as my original numbers to start with. Is you miss 1 degree, like I said, you're off by millions of miles. But what I did want to do is go back to it. That's what I wanted to do. So, our famous day, 218, that we all talked about, this is our big event. There's a huge object with a plasma conduit and a damaged ring that I talked about right there, okay? It mushrooms out, it blossoms out on a huge sphere that's right here. Okay, you see all that dispersed out in a circular pattern? That is not a normal CME pattern. This is your flow asymmetries in this are showing a bending, and this object bends light, okay? Okay, so what I was going to say about this. Okay, so this is the one I'm worried about, okay? It came off to the left of the sun, right? From our perspective, we're looking at it. It's behind we're traveling this way in front of the sun, orbiting around it this way, all right? So this happened right behind us. Something I'm looking at is the black streaks. They are also needles in reverse. You know what I'm saying? This thing has missing light, okay? I was talking last night about using missing light to see something that is invisible, okay? That's our best way of detecting something like this, is not trying to look at the object itself, but the missing light around it. You get it? Okay? We're thinking outside the box here, right? These needles are some of the angles I would be working with. And when it came in here. Let's put this. Oh, I needed the other one so I could run it a little faster. Oh, wait, I can run this faster. And when you run things faster, things are a lot clearer. Okay, so now look at this thing when it goes by. Do you see a little bit better? Do you see the other secondary object right here that's following it? That's a little too fast. But in the beginning, before this thing came, this isn't going back far enough. I saw a dark patch over here. So what I have to do is take angles from this one from the center, from this one in the center, compare them, and get a halfway decent trajectory in order to work with. So I'm using images off of this screen and stereo A and comparing them to stereo A's images. So I got 2 frames, 3 frames to which to work with here, and 3 or 4 frames from stereo A, and that's all my data. So I'm going to do the best with it I can and give it my best shot, because I believe that this event is way, way more important right now. Oh, where was that one image? It was from Stereo A on this day. That's right. Sorry, got a lot to cover tonight. I got such other stuff to show you, so I hope you guys are up to staying up late with me. Where to go here? Oh, this is not all of the data. I needed that other instrument. Anyways, it's the 18th, right? See, I barely have any data from which to work with this. Here's a good angle I can work with right here. So, all right, that's enough of my angles and my equations and shit. All right, now we're going on to, no, this one first. Yes, back to null school and our sulfur dioxide emissions, okay? Okay, we were looking at South America, at how many different of these little pock marks there are, and this event is still underway. Look at all these different individual sites. Okay, these are not like a big smoke plume or a chemical plume. These are all individual emission sites. The brightness denotes the strength. Okay, and that's just one section of this whole coast, the whole west coast of South America. Look how strong it's getting down here now, you guys, compared to the other night or last night. This is really filling in, I noticed right here. Okay. There used to be really splotchy. Now it's just all like one purple band. Okay, that's disturbing. I'm very concerned when I see readings like this, okay? And this is sulfur dioxide being squeezed out from underneath the crust. We have expanding magma that has nowhere to go. The crust hasn't released yet. We need a good volcanic eruption or a fissure to open up and release a bunch of pressure, because underneath is pressure that's pushing this gas to the surface. Okay, this is sulfur dioxide. This is emissions from subsurface volcanic activity. Now here we are in America. This is undescribable. I mean, the image speaks for itself. Now you see a lot of streaking in this. These are individual sites that have gas streaking in the wind. So we're going to come over here. We're going to put on the wind currents. And I want you to, whoops. That's the wrong, or is it the right direction? I guess that's our direction we get for this chemical. All right. So apparently here's our wind currents. This looks like upper atmosphere because this is going backwards. This is upper atmosphere winds. I got to have a lower setting on this, don't they? All right, well, never mind with the winds. You can see, whoops, let's take them off now. What I wanted to point out is you can see that we have currents that are taking, let me go in tighter, currents that are taking these splotches and driving them up this way, okay? So everybody up here is getting hit by stuff down here, and it gets concentrated more as we go up. We have a huge sulfur dioxide plume right here in between. This is all a plume, okay? This whole half of the country is a plume. You see? Boom. Now, you pick out your part of the country and just take a little look. We go in really tight on this area because this is the area of concern. A couple of days ago, I showed you uh, mag- uh, small earthquake swarming at New Madrid. Okay, look at the signature got coming off from that area. All right, maybe you guys can see these rivers and put these together and get a good reference of where you're at compared to these. All right. Yes, I feed them his name all the time. I have quite the compilation that I use as my buffet. Okay, let's come over to California here. I know we got some concerned people over here. Give us Tahoe at least right here in the Bay Area. Okay, can you see these two reference points? Right here's the top of Crescent City, so your state line goes across here, down through Tahoe, and then runs down like this. So you know kind of a reference of what California looks like here. This is boy, this is straight across from Half Moon Bay again. This site again. I looked at it before and I didn't see any kind of volcano in the area. So this is emissions coming out from a fissure or from some kind of cracks in the ground. Uh, I'm looking here just the North Bay in between Sacramento and the North Bay right here. Was that Napa? Maybe in that area. Salt Lake City, this has shifted closer to the lake now. It was over here, so now we have a little shift in that, I notice. So we're just kind of going up into Oregon and Washington for you Fugal family that are here looking around. Here, where's Columbia River? Yeah, Columbia River? Yeah, right here. Okay, so this is the little outlet right here of Oregon and Washington. Now I'll pull back. So there's our border right there between Oregon and Washington, you guys. And I'll pull back a tad bit more. Okay, boom, boom. Probably right about here. It's Washington, right underneath. Oregon's looking in good shape. You have a little spots here. Idaho, what, craters of the moon right around here. And of all places, Yellowstone looks quiet. I think all this other area is relieving pressure from this area. Okay? So we had some requests about Yellowstone, and that is this area. Okay, I'm backing out so you can get perspective again. Because it's all about perspective, folks. You really need to learn that. You've been blinded because you've been taught a wrong perspective your entire lives. Now we're looking at Mexico here. I'm concerned about their asteroids and they're going to be impacted a lot. We've already had, what, 1,000-pound one that hit the ground in South Texas. Put that on your list. 1,000-pound asteroid impacts the ground in southern Texas, right in our zone right here. This is probably a latitude zone right around here. I would say that everything south of this is going to be like impact area, all right, for our incoming debris field. It will spread. It will spread north. It will spread all over the world. So, but they're going to take the brunt of it at first for now. And as we pull back from America, let's go around the world a little bit. Look at China. China in big trouble. They have an issue. Now, this is not pollution, okay? I'm going to switch to pollution, and I want you to notice the difference between this and pollution. Go, so there we go. Did you see the drastic change? This is a pollution from a central city or, industrial hub, okay? It's carbon monoxide, all right? So you see that all the sulfur that they have, this is all just their pollution. They have a pollution problem as well. But we'll go change it back now to the sulfur, and look, it's bleeding profusely. Okay, that's what it looks like. It looks like the patient has been shot by a shotgun and is bleeding from all sorts of little tiny wounds. Okay, this is Russia. This is northern China going into Russia. Okay, here's the boy, I can't talk. Kamchatka Peninsula, Japan. No, no, that's not Japan. Japan's. Oh, my bad. There's the peninsula. So this is Japan, and this would be parts of China. Okay, that's up in Russia still. Yeah, Kamchatka Peninsula. Blah. Why couldn't I say it? All right, let's zoom back in here on Japan because we got our site right here. This is like just south of Fukushima in this area right here. Looks like they're due for an earthquake or something, right? Because we got pressure underneath pushing up. Underneath all the spots is pressure, okay? When you come over here, this is the ocean. We can't see it coming up through the water. Ooh, which reminds me, let's go zoom in on the islands again, because here it is again at Oahu, all right? You people in Oahu, stay on your toes, keep your head on a swivel, okay? Eat all these islands. This one seems to have just small emissions. This is a dark one. This is plumage coming off of it. Don't see nothing there. There's a small plume right here, just very faint, but nothing compared to Oahu, I believe it is. Yeah. Maui, Molokai, Oahu, Hawaii. I forget that one and that one, but anyways, I believe that's Oahu. And you guys at Pearl Harbor here and Waikiki and Honolulu, yeah, Honolulu, this is capital. You guys are all on alert, okay? I don't know what volcano is in your area. I'm gonna have to go research that too. That's where you guys come in. Hey, that volcano you're talking about on Maui is this one or whatever. Okay. All right. I have so much in my cup. It's hard to keep up. Now you see this plume right here. This is all coming off of China and covering over the Pacific Ocean. This all sulfur plumage. India looking a mess. It's bleeding profusely. Europe kind of, well, I was going to say not so bad, but now that I look, earlier I was looking at this and they cleared up a little bit, but now I look again and, well, I'm going to leave it right there. Can you guys see that pretty good? Let me check. All right. Pick your country. Check it out. Give you reference Spain right here. Here's the Black Sea. Turkey is right below it right here. So Turkey's bleeding profusely. Watch for more earthquake activity there. I'm telling you, this pressure needs to get released. This is what it is, okay? I'm not going to use any adjectives because I might get in trouble. Because the ones I want to use would not be French. Anyways, here we go. Here's our streak still. Some kind of weather pattern is holding this not smoke, but this sulfur in this little band here. It's been like that for a few days now. We want to go. Here's this activity at South Africa again. All right, something gonna go here. It's nice and dark right there. We'll zoom in. I don't know what land or what volcano or kind of volcanic feature right here or fault line. Okay, but we got activity in Africa as well, you guys. All right, for you people in Southern Africa, I know a couple of people from there. They're cool people as well. Everybody from around the world's cool. We just got a few people in power that have a problem and an issue. All right. Oh, that's what the other one I wanted to look at. We're going to look at Java because this was concerning me as well. This is where some of our big volcanoes and our big earthquake activity comes from. This produces tsunamis out here that are just ravage these coasts, okay? What was it? Christmas Eve was the big one. We've had volcanoes going off in this region. And if we go into the island here, I want you to look at the island of Java, the whole island. This is a country. This whole country is in one big cloud of sulfur dioxide. These poor people, their country probably smells really bad right now. Their air quality is poisonous. Okay, this gas is not good to breathe either, you guys. This is sulfur dioxide is poisonous. Okay, it's not good to breathe. It won't kill you right away, but it is not good. It creates more atmosphere over a long time. This is the volcanic process that creates our atmosphere and our air and stuff. But this is just one chemical compound that we cannot be breathing or have emitting from large population centers. Okay? And it's indicating pressure points where we're seeing seepage, where there's weakness in the crust. Okay? When you see big plumes like this is where there's weak spots. When we go to, South America, this whole rift right here, this whole rift is a weak spot. These are all plumes all the way along this coast, all along this plate tectonic boundary line. Oh, this plate, I am deeply concerned about the, no, come on, I can think of the Cusco place, or Cusco plate, yeah. Okay, so activity, watch for something in this area, because we got pressure here and pressure here. This stuff is releasing, but it's not enough. All right, I spent more than enough time on that. That was... Okay, now we're going on to this one. Now, I had a couple questions from you folks as to the fallout from Ohio. Here we go. Is this far in as I get to zoom? It's 150 I get to go. I think. Well, let me go in one more tighter. Alright, well, I'm trying to get this pulled up for you guys, but it looks about as tight as I can get. Here's your central point from Ohio where the accident is, and the plume is spreading in this direction. You can see it's going out towards New York, Pennsylvania. Boy, New York's really getting hit. Parts of it looks like Maine might dodge a bullet, but all this area, okay? Let me move my wand here, and I'm going to remove it so you guys get up close and friendly with it, because this is important for you guys, okay? This wasn't easy to find either, so probably because they don't want you knowing. Alright, get a good long peek at that, alright? You see your reference points. Okay. That's another poisonous gas, you guys. Be careful going outside. I'm sure I've been watching plenty of reports. We're not going to go into them. I just do the scientific research on it, okay? And spiritual research, okay? All three fields of physics: physics, astrophysics, and metaphysics. All right. Also, something here. We can pull this up. This little graph is also important. Let's see if we can squeeze them both in the same frame. All right. This is height, okay? This is the height of the plume going up as it spreads. All right. Just have to zoom out. Just give me one more back up. There we go. I'll leave it there while I take a sip. You guys can evaluate. Your scientific minds are now opened. I took a big key and unlocked your brain so you can see some reality. Okay, here's the height of the plume. It's coming here. It's getting taller and off the page as it gets over here. So everybody from like this point, this is where it's at ground level. Let's go straight up. So right where this black stops, okay, is basically pretty much down to zero, down to ground level. It's right where this blue line starts, right about here, that it starts to lift and go up into the upper levels. Something we need to put on the list too, and this is a side effect from the sulfur dioxide as well as this gas in the air is acid rain. Go ahead and write down acid rain because you guys are in it. Everybody that's down from this, when this gets into the upper atmospheres, mixes with the clouds, it's going to come back down as rain. And I don't know if it'll make it to London, if it's going to, it doesn't appear that it's still lifting. So we need to get, I'd say maybe another 1,000 feet. Here's 10,000 feet. Once it breaks this line at 10,000 feet there, that's when it's going to get caught up in those jets up there and start going around the world, okay? This will disperse around the world eventually. It'll be in smaller particulate count, but there is no removing this from the air. It will be with us for eternity, but which isn't much longer anyway. So you can see, here's your plume, folks. I tried to give you a good reference so you guys know what to expect. And you can look up side effects of the poisoning that's going on and what to expect and take your own precautions. You guys are smart. Okay. On to the next one. I can't really respond to your chat right now because I got a lot to cover. So we did cover a lot already. So we got the space weather, we got the Schumann, we got the carbon monoxide, but the sulfur dioxide is the one we're concerned about. I showed you the object coming off the sun. Oh, that's something else I wanted to go to. All right, now I need to go back here. Thank you for refreshing my brain, bro. Okay, pull back from this, and let's see if this was still going to work for me here. You know what? It's still frozen up. But that's okay, because it's frozen on the image that's most important, and it's actually not moving. We are actually frozen on the image, so you can study this for a minute, okay? This is our current conditions. This is the X flare that I showed you the other day, that blinking one. The Earth-directed X flare hit us today, 3 days after it went off. Here's our impact, showing red, impacting both stereo A and the Earth, the yellow dot, with red, okay? There's a big old zone of red with orange and I mean, that's a pretty good impact. That is the impact we took while the Schumann was weak. Okay? You guys feel a little weird today? Did you feel sick? Did you have any problems or issues with electronic devices? All the list that I gave you last night at like 3 in the morning. I had to do it. I had to get it out there as soon as the revelation came to me, okay? So we had that big X flare impact here while this was down. I'm going to see if that impact is caused this, but I believe that our previous impact here, the timing of it stopped the core at the wrong time while being impacted by that X flare, and impacted. This was okay. This is today. Here's our event on the 18th. Okay, so here we are at the 19th, and now we've had another CME come off, which is going to do even more disruption to this. Now, where? So I was the EMP or not? I started reading the chat and got pulled out of my train of thought. So we have these weakening while the CME is heading. Okay, so today was not a good day. All right, I hope you guys are feeling okay. Now on to tonight's gem. Oh wait, the other CME that they showed on the moving model. The moving model. Oh, wait. How did I find that moving model? I have to. Bear with me real quick. I remember seeing it somewhere. I'm going to try to find that real quick and mute. Who had that open? Was it who had that? Let me just see if it's standing out. No. Let me just check real quick. Whoops, wrong one. Bear with me. I'm sorry. This part's probably boring for you guys. Where did it go? I love your guys' comments. You guys are doing awesome, by the way. I'm just trying to get to this right here. Yeah. And we'll mute it. Sorry, Oppenheimer, but we're using you as an educational tool because that's what you report on. We're going to skip an ad. Back. Right where I needed it. I think. Oh, this is a different one. Okay, that's right. So we have an argument between NOAA and NASA on this event. All right, let me zoom this in. He's reporting that these models don't add up, okay? NOAA is disagreeing with NASA, okay? That's not normal. They're usually on the same page of narrative. This appears to be our explosion, the big one that I'm worried about. Because other ones have not shown this one. Okay, I believe that's it right there. This was, I think this is NOAA. Yeah, this is NOAA. The NOAA site. Okay, it's coming out. We're right here, just like on the other spiral. And this one looks to sideswipe us, but you see stuff trailing with it? It's a full halo CME. It's still going to give us some kind of some kind of pulse, okay? So let me zoom back out of this and cancel that. All right. That's what I wanted to show you on the endless spiral that we had no activity on. All right, so we have that impact, and then we have the endless spiral come along. Now, for our gem tonight. Okay, let me do a little bit of enhance there. Now, before we start playing this, we're going to come over to our list here because we have other things to add. We were left off with what, black hole, dark matter. We got into it deep last night. You guys got like $1 million astrophysics lesson for free. That was pretty cool. I had fun doing that. So anyway, so our next, underneath those, wherever you guys are left off, we had dark streak, dark patches, missing light, okay, and dark matter. Now, after that, we're going to go into another field of gravity, all right? Gravity is a very complex field. So I want you to write down gravitational anomaly. Gravitational anomaly. All right, these gravitational anomalies are caused by these objects going by with their gravity pulling upwards on us, as well as magnetic forces, repulsion forces. Magnets repel each other as well. Repulsion forces from underground, coming from up underground and lifting cars off the ground. Okay? Now, that's what happens. Cars are made out of metal. You ever seen a crane come over and the magnet sticks to the top of the car and they pull it away, stick it in the junker, right? So cars have a lot of metal that is ferrous or non-ferrous. Oh, I can't even think. It's magnetic, okay? We'll kind of skip the technical terms. Magnetic cars have a lot of metal, okay? So a really powerful magnetic surge or force could cause a disruption. Now, this video has been seen all over the place, and I love this video because it debunks my theory, okay? I love debunking stuff as well, all right? I'm not here to prove points. I also debunk stuff as well. So here's an effect that I was imagining would happen. I was watching NASCAR today, and it occurred to me if we were having these X repulsion sites, these like focused magnetic repulsion sites that could focus on a certain little spot on the surface of the crust. It could be as big around as a dining room table, depending on the strength. It could be the size of a block. It could be the size of a city, you guys. Especially with the direction we're going. All right. So I'm going to play this first, and I want you to watch carefully. Now, boom. You see these cars lifting up and then sit back down? What? Wait, what? 3 cars appeared to start levitating at the intersection in China. Okay. Next to your gravitational anomaly, I want you to write down levitation, or the opposite would be heaviness, like you're twice your weight because gravity is in a spot that's sucking you down. It's a gravitational anomaly, either lifting you up and repelling or pushing down and shoving you into the ground. Okay? So that's our on our list now, okay? And here's examples. I said levitation, heaviness. Oh, and pressure, okay? Pressure comes with it too. Downward pressure is going to like force people to the ground. You won't be able to stand up and walk, you know? You're going to feel like an invisible hand or this heavy pressure of force pushing you down to the ground. Also, repelling forces pushing you up. You'll appear lighter and want to lift off the ground. So now we're talking about gravity, and now we're talking about gravitational anomalies. Start looking for stuff like that. Weight differences in objects. That could cause satellites to come down. That could cause all kinds of disruptions. Now, with that in mind, let's continue this. It made no sense. I wonder why. Seriously, though, what happened here? A steel cable got caught in a passing street cleaning machine. Look at this. Bing. Makes sense now? See the cars flip? See the cable on the ground? See the damage it did to these cars? It's strung across right here, and it grabbed those cars once it got tight and lifted off the ground, right? You get it now. All right. So, just debunked my theory, right? Right? Well, not quite. Now, I want you to watch closely. This one, let's see if I can zoom in. All right, we're just going to let this play for a minute. I want you to think real carefully about cables. Is there cables lifting these cars off the ground? I need to zoom in for you. It's not showing up on the screen the way I want it to. Oh, that was too much. Okay, so while you're studying this event and you're staring at the cars, I'm looking at everything else besides the cars, okay? There's a lady walking on the street that reacts to this. The third car, first car, second car, third car sees it. Oops, I need to go lower. I'm too zoomed in. Don't look at that yet. Don't look at that yet. Okay, first car lifts off, second car in the same spot, third car sees the spot and slams on his brakes. He doesn't want to go flying in the air. He's looking at these cars levitating in the air going, what the? All right. Over and over again, there's this lady at the very beginning down here in the corner, right here. She turns just as it happens. She's looking like, what the heck? This guy slows down to look. All these guys are reacting. I look for reactions. Not, when something like this happens, I listen to people's voices. I read their body language. I look at all the other stuff that everybody else misses. Her reaction. This car reacting. This guy, he sees where the edge of the force field is. Now, I'm telling you, these force fields can be different sizes and different shapes. It's not affecting these cars. It's a circular patch. Watch. This car gets lifted up. He slams on his brakes, but gets sucked into it. So Stop watching the first car. We know what he does. Watch the second car. He slams on his brakes to avoid it, but gets pulled in. See, the magnetic force pulled him in and sucked him up. Okay? And this was happening in China, you guys. Remember what I was talking about China being in big trouble? They have cars levitating in China. Okay? Now watch this over and over again as these cars, there's no cable. What I would love to see, if whoever took this video, if they were smart enough to record the entire incident, because I would love to see what happens when these cars come down, okay? I mean, I wouldn't love to see what happened, but we need to know what happens when this magnetic anomaly takes place, okay? Back to my list here. I'm sorry. While you guys are studying that and talking, I want you to really look at this. Study this car. He has no idea until it happens. Okay? This guy sees it but gets sucked in. This guy stops right on the edge of the force field. It's a force field. Magnets use magnetic fields, force fields that are invisible to repel. This is one of the repel spots right here in China, all right? It's not a cable, okay? There's no cable lifting these cars off the ground. This guy's freaking out. Imagine being in one of these cars, okay? I want you guys to wrap your mind, this is not a joke, wrap your mind around what it would be like if you were driving along and you ran over a magnetic anomaly. Okay? I want you to think long and hard about that for a second. Okay? As I go back over to my list. Also, we're going to add another term to the list called magnetic positioning, okay? When you have bands and layers of magnetic fields, certain things can be lifted and positioned and held in a certain spot, like the bird I showed you the other night. That bird is being pinned into that spot in the air magnetically. There is blood inside the bird that has magnetic charge to it, and any field can, react on a physical body. It doesn't have to be made of metal. Get it? So as you're watching these cars levitate off the ground, and you're writing down magnetic positioning, then we need to, okay, now we're going to, this is all the gem, all right? All this stuff is tonight's gem, these cars levitating, all right? And now, something I need to point out. This street, I want you to estimate how fast they're going on this street, okay? Pretty slow. It's a city street. Cruise around 35, 40 miles an hour, nothing too big, right? Ask yourself, how fast do you drive, huh? Honestly, you lead feet out there. I drive amongst you. I know you're on your phone. You're going 10 over the speed limit. No idea what's going on, right? Until somebody honks at you or whatever, or you're on my side observing all this and fighting your way through traffic, right? So, I'm about to play a video here. And now this isn't magnetic anomaly, okay? This is not the effect. This is something I want you guys to put inside your head and think about when you're driving along and one of these magnetic anomalies pops up here. If we start enjoying these ideas that I'm saying, not enjoying, but if we start entertaining these ideas, we might see something like this. Now, this is not a representation. This is just a video. Okay, driving along, doop, 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 doo, not even paying attention. It's all good. This guy was. Now, there's two more things I need to put on this list. Now, this car hit the off-ramp, the Let's stop right there. Okay, let's back up a little bit. It doesn't really matter. You see these bankments when you're coming to an off ramp and you hit one of those slopes? You know what I'm saying? She launched off that slope at, say, 75, which you guys drive at, right? Hit the telephone lines. Bam. Okay? Now, a magnetic anomaly could thrust your car in the air, just like we were witnessing in China. If you were doing 75 and you got a sudden pulse from underneath that lifted your car almost like a jump, okay? This is why you guys need to pay attention on the road. This wasn't the car that it happened to. He's just driving along. I'll let it show you one more time. Okay? That's what I would imagine if you were doing 75 to 80 and you hit a magnetic anomaly. Now, she launches off this dirt, so this is not the magnetic anomaly I'm talking about. I'm giving you the Dukes of Hazzard effect, okay? Because I want you guys to now wrap your mind around this part. When we're having magnetic anomalies that are disrupting electronics, how many of you guys are driving something that's, say, under 1980s with a carburetor and it's all throttle cable, no electronic assist, anything? How many of your cars are all run by computer? One of these magnetic waves hits your car, it disables your car, right? Your power steering goes out, your braking system goes out, everything goes out at 75 miles an hour now, right? All of a sudden, you're Dukes of Hazzard, aren't you? Do any of you guys know what to do when your car shuts down at 75 miles an hour? You better go look up how your car works and what to do and how to react. You want to, if your brakes aren't working, you go for emergency brake, pull off to the right, get out of traffic. But cars might be shutting down at weird times, at weird spots. Possible magnetic pulses from the ground thrusting up. I showed you them coming out of the earth in the forms of CMEs. You could have a magnetic repulsion thrust that could launch your car like this at 75, 80 miles an hour and throw you in the air. It could also disable your car and you could hit the hump on the side of the road doing this, okay? So there's two different ways this could start happening, all right? So think about it. When you guys get in your car, you know what I do? Every time I leave the house, I say a prayer before I go out because I know I'm battling a bunch of driving around. And then we got factors like this underlying that nobody even knows about yet. Only the elite, you guys watching my channel, are the elite. Everybody else, no clue what's going on. But you guys are getting clued in. Let's watch this again. I want you to think what it's going to be like when you're in the car. Do you wear your seatbelt? Do you have an airbag in your car? Huh? Do you carry kids in the front seat? What's hanging out loose in your car that's going to come from the back seat and just slam you in the back of the head? Huh? Think about your stuff when you're doing it, really, because lives are at risk and lives are at jeopardy. And she hits the telephone lines. That is some hang time. Okay, so while we're learning all sorts of wonderful things, take some stuff into consideration and not necessarily flinging cars off the road. We're talking magnetic anomalies that could do other things, lift other metal objects. We're talking about weightlessness and heaviness and possible magnetic effects shutting your car off at high speed when you're on the phone. Okay? I'm guilty. I have texted and sent a message like once, but I pull over. The only time I did it once was it was such an important thing and I had to make it through. If I don't make it through this patch of traffic, I'm not going to make it to this destination the texting is coming from. But otherwise, pull over to the side. It's not worth it, you guys. And I would start watching your cars closely. My battery has been draining every night. I have a brand new battery, took it tested, the core's fine, everything. I hook it up to a battery charger overnight and I come out in the morning with less charge in my battery than when I hooked it up to the charger all night. So watch for depletion in your batteries. We're talking depletion in, like, maybe your cell phone's burning out faster than they usually do. Your daily charge doesn't last, your 100% doesn't last all day. Stuff like that you'll start noticing. That was the other thing on the list. Where'd it go? Go. Okay. So along with that, now we also have this magnetic radiation is going to affect remotes, like remote control for your TV. My son has a remote control truck, and we race that thing. And there's odd behavior happening with our radio waves affecting remotes and remote controls. So if you drive one of those remote controlled cars, like say a Tesla or one of the ones that is an adult version of a remote control car, and you're not holding on to the wheel and you think it's fun to drive with computer assist that relies on satellites that can be taken out by any kind of magnetic pulse, you're really, really, really rolling the dice. Okay? So, just thought you guys would find that fascinating because I did. And, it could knock down telephone poles and you're going to be running over a cable and launching into the air. So, a lot of stuff to think about. There's a lot of lessons to be learned by this mistake. And this was a hit and run. It just sent her off of this launch. But I'm trying to tell you how it could launch you when you're doing 75, 80 miles an hour into one of these repulsion zones. Okay? So, just be aware. Drive carefully. Maybe this will be a little wake-up call, too, that you guys know that other stuff is possibly happening and that you could get the sensation of feeling light or heavy when this object passes by. Okay? I feel like staying up late, and I got to erase all these clicks and come up with new stuff, but I might be back in about an hour with an update, because what's happening over here at Null School with these sulfur dioxide emissions is just, I can't use the terminology, but you guys can look at it, all right? This is nullschool.net. Okay, you go over to nullschool.net, you pop open, hit Earth, it'll pop up your chart. This thing's a little difficult to figure out. Once you can get it to pop up this little box, when you put your cursor on it, you can start going through and deciphering what it does. Play around with it a little while. The air currents, that's the one we use a lot. We were on chemical. Okay, see, air, ocean, chemical. This is for the SO2. This is for our air currents that we use. Okay. Let's go to the troposphere and check out real quick. Yes, I forgot to do this part. Our polar jet, or our polar vortex, is still acting all weird. Put the currents into motion for you. You come over here, hit play. It'll stop and start the winds for you. Okay, click off. Here's the split polar vortex. Okay, it should be one thing going one direction. It's split, so you're getting opposite flow. See how one's going one direction, one's going the other? And this thin line, this zone right in between. See this blue zone right in between? There's hardly any wind in this zone, but it's extremely fast there and extremely fast here. It's like a split current, and if you follow it, it goes all the way up into this thing, double backs around, half of it feeds back into itself, then it splits and goes the opposite way. So we're going to get our reference points. I think you can see America there. Yes. Okay. Yes. This is the upper level jet. Okay. It is going backwards right here. All right. It should be going that direction. All right. But it's going backwards. This is up above our weather. Okay. Let's go down just a few levels here to this level right there. Okay, now you can see below the troposphere in our weather zone, the air's going the opposite way, right? Those two currents are fighting each other. At a certain zone, at a certain elevation, these two currents rub up against each other, causing these to slow down and also speed up. You see these huge dips right here. This is taking cold air out of the Gulf of Alaska, funneling it way off the coast of Southern California, and then shooting it right across the Baja Peninsula. They're getting snow in Mexico because of this violent drop. This is caused by our split level vortex up above. And see how it's disrupting this, making it all weird and jumbly? It should be a nice smooth round circle. Well, we're in transition right now, but this transition is not normal. Okay? We have another huge dip like this. That's just west of Hawaii. So let's go back over to America. Sorry I'm moving around so much. But you see how extreme the weather is going to funnel moisture, cold and moist air, both combining here in this white streak. That white streak is, let's see, going right across, coming up in over Texas and going right over Ohio area. Okay. So you guys are going to have a lot of weather funneled in your direction. All right. So you guys know how to come over here and play with this a little bit. In between streams, you can come over here and check it. If you guys notice something, you come over here and, I'm out doing my thing during the day and you come over. Oops, you're playing with this and you come over and you clicked on chemicals to see the different chemicals. Here was carbon monoxide, here's carbon dioxide, here's sulfur dioxide. That's the one, sulfur dioxide. And you come over here and you learned how to turn off the winds and you saw a new plume come off in a spot that I haven't seen, or something that is very concerning. You see a major hub or where you live or where your family lives going ballistic. That, like a spot over here that's going ballistic. You tell me in the chat or in the comments, or make your own video maybe, Okay. Anyways, I'm going to leave that image there for just a second so you guys can soak that up, okay? This half the country kind of in good shape. Everything from that side over, I'm very concerned about. Really, an earthquake in this zone right about now would not surprise me at all. Okay, so you guys here at the New Madrid, let's watch that instrument closely too over at New Madrid. And this earthquake swarm that's going on over here, it's really small earthquakes. They're not on the USGS. You have to go over a different site to see the University there of Tennessee is I believe putting out some information on it. So I think I covered a lot. I think I covered most of it. I might not do an update unless something else pops off real quick, but hopefully you guys learned a lot tonight. We got a lot of stuff going on, a lot of lists to look at. Oh, somebody was asking about the list and what date I was expecting all this to happen. All this is happening currently. Your whole list is playing out right now. All the stuff that I was telling you on this list are all the side effects that Ben started off talking about happening to other planets. So when I see side effects happening to other planets, I expect to see those here. Thus, our list. Okay? It's not a count. It's also a countdown list. As we're checking this stuff off, it's happening. We're checking this stuff off of the list. So for you, those of you who are keeping your list, and I had a question, what timeline? There is no timeline. This is currently happening. Okay? Um, as far as dates, you guys, I don't like to set dates except for when we have a CME come off the sun that takes about 3 days to get here. So that's one last thing I was doing in my reports that I forgot to do. Today was the 19th. Tomorrow will be the 20th, okay? So I want to go 3 days back from the 20th and see what happened on the 17th so we know what to expect tomorrow, all right? This is how we fortune tell a little bit by taking our 3 day advanced thing, looking backward so we know what to expect. It was this event that started it all off, right before the big one. Okay, so not much on the 17th that we have to worry about tomorrow. Okay, the day that I'm most concerned about, yeah, that's not even really Earth directed or anything, so we don't have to worry about too much tomorrow. We had a good impact today, all right? That's more than enough. But this was our big day, the 18th, and I showed you the big object, and it takes 3 days. So that would be the 21st, right? So everybody brace for the 21st now. We all braced for the 18th and we saw something, right? I'm going to take a forecasted, a good guesstimate at watch out on the 21st. Okay? And let's see. We just went 3 days back from there. So probably nothing tomorrow. But I would watch out seriously on the 21st. Okay? That's how it's done. Okay? Not too hard. It's not too hard at all. It's basically and simple. I try to simplify it so you guys can grasp it and understand a little bit better here. Maybe we'll just close out with this, you guys. Should we close out with that one again? All right. I think that's going to be about it for tonight. Everybody wear your seatbelts. Keep your kids safe in your car. Slow down. Pay attention. Pull off if you need to use that cell phone. Car could shut down. You could hit a magnetic anomaly. All kinds of crazy stuff. All right. So just be cautious. All right, folks. No pulling the Dukes of Hazzard here, okay? All right? And pray every time you go out and you're driving around. It helps. Pray for protection. He'll save you from this happening. Trust me. All right, that's it for tonight. Love you all. I miss you all. And I might do another update in about an hour. Until then, bye.